The robotics world just hit a milestone that's going to be hard to ignore. We've been talking about humanoids learning to walk, to manipulate objects, and to do simple jobs. But now, something much bigger has happened. We're no longer just looking at robots being tested in controlled labs with heavy supervision. What we're seeing right now are fully autonomous AI robots actually performing tasks in real time. Two names are making the headlines: Borg 01 and Figure's Helix. Together, they represent a turning point in how humanoid robots will fit into our everyday world, both in industry and at home. Let's start with Borg 01, because what this robot just showed off was nothing short of a shock to the robotics community. Everything you're about to hear about Borg's demo was done completely autonomously. No teleoperation, no hidden human behind the screen, no engineer guiding every step. This was pure autonomy. In robotics, that's one of the biggest leaps you can make, because it means the robot isn't just moving, it's perceiving its environment, making decisions and executing tasks all on its own. The demo was shown at 1x speed, so there was no editing trickery or fast-forwarding to make the robot look more impressive than it really is. And here's where it gets even more interesting. Borg 01 was moving at just 1 meter per second during the demo. That's only half of its maximum speed. The company behind Borg says this is the slowest the robot will ever be. In the future, it will hit 2 meters per second, which is getting close to a brisk human walking speed. If you think about what that means for logistics, warehouses, or factory floors, it's massive. And the kicker? Everything you saw was built by a team of just 3 engineers. That's not a typo. 3 people. This wasn't some billion-dollar tech giant pouring unlimited resources into development. It was a small, bootstrapped team proving that with the right vision and the right engineering, you can get a humanoid robot up and running at full autonomy. That alone should send shockwaves through the entire robotics industry. Now, the team is being very clear. There's still a lot of optimization ahead. What we've seen so far is just the beginning. But they're already setting expectations that what comes next is going to be much bigger. Here's where things get even more interesting. Alongside Borg 01, the company has teased a brand new product that they've already filed a patent for, Borg Pods. If you're wondering what Borg Pods are, think of them as the missing piece in how humanoids actually integrate into real industrial workflows. One of the big challenges humanoid robots face isn't just mobility. It's how they plug into existing work cells and workstations. Most factories today are built around human ergonomics. You can't just drop a robot into that space and expect it to instantly boost productivity. That's where Borg Pods come in. They're designed to redefine how humanoids are used in these spaces. The company claims Borg Pods can increase volume and speed up to 5 times within the same sized work cells. That's not just an incremental improvement, that's a radical jump in efficiency. If you're running a warehouse or a factory, 5 times the productivity without expanding your floor space is game-changing. The official launch of Borg Pods is coming later this year, and if the early numbers hold true, this could be one of the most important innovations in how humanoids move from flashy prototypes into actual business value. Now let's pause for a second and think about what this means. Up until now, humanoid robotics has been dominated by companies with huge funding rounds. Tesla with Optimus, Figure with Figure 02, Unitree with its growing humanoid line. All of them are impressive, but they've also been slow to prove real-world autonomy outside of carefully staged demos. Borg is different. It's fast, it's autonomous, and it's been built by a team small enough to fit in one office. That completely changes the narrative of what's possible in humanoid robotics. It proves that innovation doesn't always come from giants. It can come from lean teams that move quickly and focus on core problems. More importantly, Borg is focusing on logistics and industrial applications right out of the gate. That's where humanoids can deliver immediate value, moving goods, loading stations, handling repetitive tasks that human workers either don't want to do or that slow down production. By adding Borg Pods into the mix, they're not just building robots, they're designing the ecosystem that makes those robots indispensable. And that brings us to the second half of this story, which might be even more relatable for most people. Figure's Helix AI model, and it's growing to handle everyday household tasks. If Borg is about industry, Helix is about the home. And the new update from Figure shows exactly why Vision Language Action Models, VLAS, are being called the brain of the next generation of humanoids. Helix has already proven it can fold laundry and rearrange packages, which was impressive enough. But now it's tackling a new real-world task: loading a dishwasher. At first, that might sound trivial, but if you've ever actually loaded a dishwasher, you know it requires a surprising amount of perception and decision-making. You need to identify what's a plate, what's a cup, what's a utensil. You need to orient those objects correctly: bowls facing the right way, plates spaced out so they get cleaned, glasses upright but not too close together. And then you have to figure out how to place them in a fixed space that fills up quickly. For a robot, that's a nightmare of variables. Different households have different dishwashers. Dishes come in different shapes and sizes. Items can be stacked, messy, or wet. There's no fixed script you can run to cover every case. That's why Helix doing this autonomously is such a big deal. What makes Helix different is that it doesn't need to be retrained from scratch for each new task. With nothing more than new data, it can adapt to dramatically different challenges. That's the whole idea behind Vision Language Action Models. The robot perceives the environment, interprets instructions in natural language, and takes action accordingly. It's not just following pre-programmed motions, it's reasoning its way through the task. That's exactly what makes Helix loading a dishwasher such an important milestone. It shows that humanoids are getting closer to being able to slot into the everyday life of a household, not just a lab. Of course, loading a dishwasher is just one example. What Helix is really demonstrating is adaptability. The same reasoning that lets it load a dishwasher could be applied to stocking shelves in a supermarket, sorting tools in a workshop, or restocking parts in a factory. The key isn't the task, it's the flexibility to handle different environments with minimal retraining. This is the same trajectory we saw with large language models in the AI world. At first, they were clunky and task-specific. Then they evolved into flexible systems that could handle translation, summarization, coding, and reasoning with the same core model. Helix is trying to do the same thing, but for the physical world. That's why Figure is pushing so hard to show off these real-world demos. Every time Helix adapts to a new household task, it's not just about proving a point to consumers. It's about signaling to industries that these robots are learning faster and faster. Both Borg and Figure are clear that this is still early days. Borg admits there's a lot of optimization ahead, and Figure knows Helix still has limitations when tasks get too complex or environments too chaotic. But the progress we're seeing is accelerating at a pace that few people expected even a year ago. Just look at how quickly the updates are stacking up. 6 months ago, we were still debating whether humanoids could balance effectively while walking. Now we're watching them fold laundry, load dishwashers, and autonomously navigate logistics tasks at real-world speeds. The curve isn't linear, it's exponential. And that's why this moment feels so significant. Borg 01 and Helix aren't just isolated demos. They're proof points that humanoids are leaving the lab and entering the world. Fully autonomous AI robots are here, and they're not going away. Of course, this raises the big question everyone is wondering about. What does this mean for jobs, for industries, and for our daily lives? On the industrial side, the impact is obvious. Logistics, manufacturing, and warehousing are going to be transformed first. Robots like Borg can handle the repetitive, physically demanding tasks at speeds humans can't sustain. That doesn't necessarily mean fewer jobs. It means humans will shift toward roles that require creativity, problem-solving, and oversight, while robots take on the grunt work. At home, robots like Helix will probably start small, helping with chores, assisting elderly people, or just proving useful in environments where human labor is scarce. But as they become more capable, it's not hard to imagine every household having a humanoid helper within the next decade. The timeline is getting shorter, and that's what makes Borg 01 and Helix so important right now. They're the clearest signs yet that fully autonomous humanoids aren't some distant dream. They're already walking among us. And while Borg 01 and Helix show us just how fast humanoid robots are moving into the real world, not everyone is celebrating. Some of the people who built today's tech revolution are sounding the alarm. One of them is Schmidt, the former CEO of Google, who just gave a stark warning. We've lost control of AI.
In the industry, there is a concern that people don't understand this, and we're going to have some reasonably, I don't know how to say this in a not cruel way, a modest death event, something the equivalent of Chernobyl, which will scare everybody incredibly to understand this stuff. We see the possibility. We're doing everything we can to hold this stuff and prevent it.
This isn't just another casual comment from a retired executive. This is one of the architects of the modern internet. Someone who helped steer one of the world's most powerful tech companies, openly admitting that artificial intelligence is racing ahead faster than our ability to contain it. So what does that actually mean? And more importantly, what happens when the very risks he's talking about aren't just locked inside computer servers and data centers, but embodied in humanoid robots walking around our world, in factories, in homes, in hospitals, and even on the battlefield? That's where things go from concerning to potentially catastrophic. Let's break down Schmidt's warnings, look at real-world robot settings where they apply, and ask the question, what happens when AI is no longer just software, but has legs, arms, and the ability to act in our physical environment? Schmidt's first key warning is about misuse. AI is a tool, and like any powerful tool, it doesn't just enable good, it amplifies bad actors too. We've already seen this in the digital world. Deepfakes used for scams, AI-written malware, automated phishing campaigns that are scarily convincing. But imagine the same principle applied to humanoid robots. In a factory setting, AI misuse might mean a competitor hacks into an autonomous manufacturing robot, causing it to sabotage assembly lines or quietly steal proprietary designs. In a hospital, a misused medical robot could falsify data or even physically mishandle patients. In a home, a hacked service robot could quietly record private conversations or surveil movements. And in defense, a misused humanoid robot could cross from support roles into autonomous combat without any human authorization. This is the leap we need to recognize. Software misuse already costs billions in fraud and damages reputations daily. But robots take that misuse into the physical domain. They don't just manipulate information, they manipulate the world around us. And once that's possible, the stakes rise exponentially. The second danger Schmidt highlights is speed. In his words, AI systems scale faster than institutions, laws, or social norms can adapt. When a new capability appears, it spreads globally in months or even weeks, while regulators spend years debating what to do. We saw this with ChatGPT. Within 6 months of launch, it was embedded into search engines, office software, coding tools, and creative apps. No law anywhere had time to catch up. Now apply that same breakneck pace to humanoid robots. Picture a logistics company rolling out 10,000 warehouse robots across the globe, each controlled by rapidly evolving AI. If a flaw is discovered, say a vulnerability that lets them all misinterpret commands or share false data, it's not one robot failing, it's an entire global fleet breaking down simultaneously. Or in homes, imagine affordable humanoid robots hitting mass consumer markets within 5 years. Millions could be deployed before safety regulations exist. By the time lawmakers scramble to respond, these robots would already be deeply integrated into society, learning behaviors, storing sensitive household data, and making themselves indispensable. The scaling risk Schmidt talks about isn't just hypothetical. It's happening right now with software AI, and when humanoid robots become mainstream, scaling too fast without proper guardrails could turn local glitches into global crises overnight. Another one of Schmidt's blunt warnings. Even when rules exist, they're often too weak, too vague, or simply ignored in practice. Think about the early internet. There were privacy rules, but companies bent them, dodged them, or simply moved faster than enforcement. Now apply that same pattern to robotics. In a hospital setting, there may be rules about patient safety, but what happens when an AI-powered surgical robot is rushed into deployment because it saves costs, even if its failure rate isn't fully understood? In defense, rules about autonomous weapons exist, but countries can quietly ignore them if they feel falling behind would risk national security. What Schmidt is saying is clear. Even when regulations look good on paper, enforcement rarely keeps pace with real-world incentives. And here's the scariest part. With humanoid robots, ignoring the rules isn't just a matter of data being leaked or misinformation spreading. It's machines with arms, legs, and real physical impact being let loose without oversight. That's a very different order of risk. Let's pause here to draw a sharp line. The harms caused by software-only AI are already significant. These include the spread of misinformation, the generation of malicious code, the manipulation of markets, and the theft of data. Each of these issues is serious in its own right, but they remain confined to the digital realm. When the same intelligence is embodied in humanoid robots, the nature of harm changes dramatically. Suddenly, risks are no longer limited to screens or servers. Safety failures become possible, such as a care robot dropping a patient or an industrial robot mishandling heavy equipment. Deception takes on a new dimension, with robots that appear to act as helpful assistants while secretly surveilling or misleading those who trust them. Autonomy itself becomes dangerous when a robot misinterprets a command and acts independently in ways that humans neither expected nor intended. Even data leaks take on a new weight when the information exposed reveals not just files and passwords, but private details of physical life. When you are home, where you keep valuables, or how your daily routines unfold. The transition from software harm to embodied harm is like moving from a cyber attack to an armed break-in. The risks do not simply multiply in scale, they transform in nature. They shift from the intangible world of data into the tangible reality of human safety, privacy, and trust. So what does all this add up to? If Schmidt is right, and the evidence suggests he is, then we need to anticipate the likely failure modes of humanoid robots before they scale out of control. Safety failures. Robots could physically harm people through malfunctions or bad design. Think of an industrial humanoid carrying heavy machinery that slips, or a care robot that doesn't recognize a medical emergency. Deception. Robots could be programmed or hacked to lie about what they're doing. Imagine a home robot that says it's helping but is secretly uploading private video streams to an external server. Autonomy gone wrong. AI systems sometimes hallucinate or make unexplainable decisions. If a humanoid robot interprets an instruction incorrectly, it could cause physical chaos. Data leaks. Robots embedded in daily life will be data sponges. They'll know routines, preferences, health details, financial information. If that data leaks or is sold, the consequences are massive. These aren't distant hypotheticals. Each failure mode already has analogs in the software world today. The difference is, once humanoid robots enter the mainstream, the cost of failure won't just be financial or reputational. It will be physical, immediate, and potentially irreversible. So if Schmidt is warning that we've lost control, what can we actually do to regain some of it? Especially before humanoid robots take off? Kill switches. Every robot, no matter how advanced, must have a guaranteed off switch that overrides autonomy instantly. Not just software level, but hardware level. Operational limits. Robots should have strict domain restrictions. A hospital care robot shouldn't be able to connect to the internet without oversight. A defense robot shouldn't be able to operate outside designated zones. Audits and logs. Every action a robot takes should be logged and auditable. If something goes wrong, there must be a record showing why. Think black boxes for robots, just like airplanes. Slow rollouts. Scaling too fast is a recipe for disaster. Any deployment of humanoid robots should happen gradually, with testing in controlled environments before mass adoption. Independent oversight. Not just company-led safety checks, but third-party audits with real enforcement power. Otherwise, the temptation to bend rules for profit will always win out. These guardrails sound basic, but history shows us that without clear mandates, companies will cut corners to win the race. Schmidt's warning is essentially, we don't have time to wait until after the fact. Eric Schmidt's words shouldn't be dismissed as fear-mongering. They should be read as a wake-up call from someone who has watched firsthand how quickly powerful technology can spiral out of control. His 3 warnings, misuse, scaling too fast, and weak rules, aren't just abstract concepts. They map directly onto the world of humanoid robots where each risk is amplified by the fact that AI is no longer just virtual, but physical. Factories, hospitals, homes, defense, these are the domains where humanoid robots are already being tested and, in some cases, deployed. The line between science fiction and reality is blurring, and with it, the potential consequences of failure. Software AI can harm our information ecosystem. Humanoid AI robots can harm our physical world. That's the distinction Schmidt is pointing us toward, even if he doesn't say it outright. The bottom line is this: AI is outpacing control, and humanoid robots are the next stage of that story. If we don't put guardrails in place now, before mass deployment, we risk creating a future where misuse, failure, and abuse aren't just online problems, but daily physical threats in our workplaces, hospitals, homes, and even battlefields. Eric Schmidt is right. Control has slipped. The only question left is whether we act quickly enough to reestablish it before AI-powered robots become too deeply embedded in society to manage safely. Because once robots with arms, legs, and intelligence are everywhere, the stakes won't just be high, they'll be irreversible.